All right, good morning. Thank you very much for coming to listen to me. So what we're going to do today is it's literally 10 minutes, and I'm going to do an introduction to graphs. So when I talk about graphs, I don't mean these. When I started work at Neo4j, I started to refer to these as charts, right? What I mean by graphs is I mean these. I mean graph theory. I mean nodes and relationships, circles and lines, vertices and edges, however you want to define them, but the relationships between things. So Neo4j is a graph database, and it stores data using this graph structure. So let's just talk about how it does that. So first of all, everything in Neo4j is defined in one or two ways. It's either a node. So if we imagine a node as a circle within a graph, a node can typically represent a thing. So it can represent a movie, it could represent the movie Toy Story. Yeah. But it could also represent anything. A desk, a laptop, a person, a customer, an account, a transaction, right? A product. And we call these nodes. Nodes represent things, and we can categorize nodes using labels. Labels is how we group nodes together. It's how we describe them as being the same thing. So Toy Story is a movie. And you can also identify things by multiple labels. So Toy Story is a movie. It is also an animated movie. Yeah. Labels are how we categorize things together. We can also store properties against nodes. Properties is how we store data within the graph. So in this case, the node that represents Toy Story has two properties. It has a title, Toy Story, and it has a release date when that movie was released. But we can store as many properties as we want. Where graphs become powerful, where the kind of the real value is in the relationships between nodes. So we have another node called Tom Hanks, who is an actor. We have the movie Toy Story, and there is a relationship between them. And that relationship has a type, in which case Tom Hanks acted in the movie Toy Story. Relationships always can connect two nodes. They have a type, they have a direction, but they can also have data. So you can store data against relationships within Neo4j as well. So in this case, Tom Hanks, the actor, acted in the movie Toy Story in the role of Woody. Right. And that's how we store data within a graph. And this structure is incredibly useful where you have highly connected data. So let's have a look. So what I'm going to have to do now is hold a microphone and type. So we're going to see how this goes. So this is Neo4j query or browser. It is the way that we can interact with the Neo4j database. So what I have here is I have a database of movies. It's that using that use case we just had a look through. So these are, if we zoom in, these are all nodes, and each one of these nodes represents a person. So here is Edna Pendleton. Here is Mae Marsh. We have more data about Mae. Mae was born in 1894, died 1968, and then a little bit of bio information. We can see by the labels that we store against this node that Mae was a person, obviously, but also Mae was an actor. And if we expand the nodes from Mae, we can see that Mae has an acted-in relationship to a node, which is a movie node, with a title property somewhere, which is the birth of a nation. So we can see through our graph that the person, actor, Mae Martin, acted in the movie, The Birth of a Nation. And we can expand any of the relationships from this graph. So I expanded the relationships from that movie node, and we can see the other people who have an acted-in relationship to that graph. Okay. All right, so because I'm finding it difficult to type, I've got a few saved queries. So let's just have a quick look at this query. This is Cypher. So Cypher is a query language. It's a declarative query language, so we describe what it is that we want, the data that we want. Just familiar with SQL, SQL is another declarative language. You describe what you want, not how to get it. So if we look at this query, we can say, okay, well, I want to match something. I want to find some data. And we describe a pattern. And this pattern describes the data that we are looking for. And in this case, we are looking for a node. We know it's a node because it has round brackets on either side. Yeah. We can see that we are looking for a node with a label of person. And we can define some data. We can define some data about the node that we are looking for. In this case, I am looking for a node that has a person label that has a name property that is equal to Tom Hanks, right? And then I'm going to return Tom. I'm going to return whatever node that I find. So not unsurprisingly, when I run that, I get one node back, which is the node that represents Tom Hanks. And again, if I click on Tom Hanks, I can see the properties that are stored against that node. And if I expand the relationships from Tom Hanks, we will see that Tom Hanks has acted in a whole host of different movies. And if I look at the relationship, so I can see the role that Tom Hanks acted in that movie. All right. So let's have a look and see, okay, well, I've got a new query here, another Cypher query. And again, it works in the same way. I'm using match. I want to find something. I want to find a pattern within the graph. So the pattern that I'm looking for is Tom Hanks, the node Tom Hanks, any acted in relationship to any movie, to any node that has a movie label. And again, I run that and I get the graph back that we saw, right? All of the movies that Tom Hanks has acted in. Right? But we can make these patterns as complicated or as simple as we want. So what I have here is I'm looking for the person Tom Hanks. I'm finding the movies that Tom Hanks acted in. And then from the movies that Tom Hanks acted in, I'm finding the people who acted in the movies with Tom Hanks. Right. And if you're used to kind of data and you're used to using SQL, this idea of a cyclic query is extremely difficult. But in a graph, it's very easy because there is no concept of a table. Everything is an entity. So what I get back if I run this is, if I press the button, if I run this, is I get a graph of Tom Hanks in the middle, all of the movies that Tom Hanks has acted in, and then all of the people who have acted in the movies with Tom Hanks. Right. Let me just modify this. So what I'm returning here is I'm returning the elements in the graph. I'm returning Tom, the node that represents Tom, the relationships between Tom and those movies, and then the relationships between those movies and the other people that acted in. I can also return properties. So I want Tom's name. I want the role that Tom Hanks played. I want the title of the movie that Tom Hanks acted in. I want the role that the other person acted in, and I want their name. So I get back a table of data that represents all of the people that acted in movies with Tom Hanks. I'm using movies, people, acted in relationships. I could swap this out for customers, accounts, products, right? And suddenly what I can find is I can find the relationships between any piece of data. So just the very last thing, because we represent the data as a graph, we can traverse the relationships very quickly, and we can also find patterns through the graph. So what I've got here is I have a Cypher query. I'm finding two nodes. I'm finding the node that represents Charlie Chaplin. I'm finding the node that represents Kevin Bacon. And then I'm finding a path, which is the shortest one path. So the one shortest path, right? That takes me from Charlie to Kevin Bacon through any acted in relationship. and I get back a path that represents how Charlie Chaplin was connected to Kevin Bacon. Right. And if we think of other use cases, so let's say, think about things like fraud detection, where I have a single transaction that's split into many, many, many different transactions that go through lots and lots of different accounts, but ultimately end up back in the same place. We have the same concept of being able to find those paths. And, you know, I look for just the shortest one, but I could find the shortest 5, and that will give me all of the first shortest 5 paths through the graph that take me from those 2 nodes. Yeah, 10 minutes. Thank you very much for listening to me. Right, I will be here for a little while. If you want to talk to any of us, please do. Thank you very much.